From the beautiful studios of Way Happy, this is Mr. Meyer in 2-3, part 2. Trig and higher order derivatives. This is going to be a quick one. So we just need to talk about how you derive trig functions. So now that we know that that sine is cosine and that the derivative of cosine is negative sine, we could use those properties to prove all the other trigs. In fact, I encourage you to try it. But for now, here it is. Here's the derivative of tangent, which is secant squared. You have derivative of cotangent, was negative cosecant squared. You have the derivative of secant, which is secant tangent. And you have the derivative of cosecant, which is negative cosecant cotangent. And we will try our best to remember all of those as we do these problems. So here's our first example. I want you to find the derivative of x minus tan x. So simple enough, the derivative of x minus tan x, it's an addition or a sum identity, or in this case, a difference identity. Take the derivative of x, which is 1, and tangent, which we know is secant squared, and you have found the derivative. Done, complete, and pretty. Trying to think if I could reduce that down any because of the fact that there was an identity that said I tan in a second, but that would give us negative secant. Ooh, it would be negative tangent squared. Just kind of neat to know. All right, so it could also be negative tangent squared. All right, what about this one? Ooh, that is the product rule, right? I see one thing here and one thing here. So you have, here, I'll write them out. F of x is x, which means the derivative is 1, and g of x is secant of x, which means the derivative of secant is secant tangent. And now what do I have to do? All right, so I have to do the original times the derivative of the other plus the other one times the derivative of the original. So here we go. I would have x times secant, oops, I forgot to say that I was doing y prime. X times secant x tangent x. So there's the original times the derivative of the second. Plus, now I better do the original of the, the second original times the derivative of the first, which in this case is just 1. And I could simplify this one down too. This looks like x secant x tan x plus secant x. And then I think I could factor out, what, a secant x? And be left with x tan x plus 1. And there you have your trig derivative. And heck, let's finish this even without stopping. What is higher order derivatives? Higher order derivatives are just exactly what you guys have been telling me they are. So we know the first derivatives now, and then you can find a derivative of a derivative, which would be called the second derivative. And like I said, if you have a falling object, you have an equation for the height of the object. If you take the derivative, that tells you the velocity of the object. And then if you take the derivative of the velocity, that tells you the acceleration of the object. So this is why, and this will work in different things, but here's the notation that you need to know. It could be, we'll either do the primes with the, single prime or double prime or triple prime, or then the little fourth exponents. You might see as the dy dx stuff here in the middle column. You might see this saying take the fourth derivative. So that means go through this and do the derivative until you take the fourth derivative. And then, the other two ones are also very common. So there you go. That is higher order derivatives and what they look like, so you know what you need to do to take them. Have a great day. Stay happy, and I'll see you tomorrow.